Okay, hi. This video looks at 5K, calculus with other bases. This is the last section in this topic before we go on to our new topic. Now, there's two ways to think of these questions in this topic. You're given them the way to work them out basically on your HSC formula sheet, which is really handy. Okay, and I'll flick over to there in a second. So we can substitute those in, but it's nice to know why we're doing things as well. So we're basically looking at questions like this first one down below here, log base 10 of x, where we're not working in base e. So we're working in other bases. Over here we're working in a base 3. So I'll just quickly jump over to the HSC formula sheet and show you where our things are today that we're going to have a look at. So if we jump in here, oops, sorry, I'll just move down a little bit. So we're looking at our differentiation and our integration. So we're looking on the sheet at this part in here, okay? Y equals a to the power of f of x, and we're differentiating an exponential that our base is not the e. We're going to have some other function. So when I differentiate y equals a to the f of x, my derivative is going to be log of a, f dash of x, a to f of x. And we will have a look at that in a second. Likewise, over here, here's the format that we're given when we're integrating an exponential that has a different base value other than e. And that's what it's going to have a look at. So you've got those to move back to when you're working out these questions. And I'll have a look at these with you on the sheet here. Here they are, the different versions. And the two that we want to have a look at are, I'll just highlight them, the bottom couple down there. The blue ones down there. Okay, but let's work out if we can figure out how to work them out without using those laws and using the laws that we know already. So basically, if we've got something that has a different log base other than a base e, we need to use our change of base formula, which is going to say that I can write this as log of x, sorry, on log of 10. And they're equivalent, and we've looked at that already. And I think that's the way that if you're wanting to fully understand it, that we would like to do these questions. Now, I want to differentiate that. So I want to find d dx of this one. Okay, so let's think what we've got there. So we have log of x, which is a function, but log of 10 on the bottom is a value. So you can pop that in your calculator and get a value for log of 10. And then when we're looking at that, we're talking about log of base c of those ones. So I can use ln for each of those. So that's a value that you can get. So basically what we have when we're finding the derivative of that, we've got this 1 over log base e of 10 is a value, it's a constant number, times log e of x. So when I differentiate that, what I get is I still get my 1 over log of base e of 10 times the derivative of log of e. When we're differentiating logs, it's the derivative on the function, so it's 1 over x. So what we end up with is 1 over log e of 10 times x. Have a look back at the rule back here that I'm just highlighting up here now. That would equate to this question here. So we've got a log of base a, we've got a 10. The format is the derivative of the function on the top line. So the derivative of x is 1. So we've got a 1 over log of base c of a. So log of base c of our base. So log of base c of 10 times f of x. And that's our x. So we've got the same thing there. So you can pop it straight into that formula, or it's nice to understand why or where we're getting that from as well. Let's have a look at the next one here. So we're going to differentiate log of base 3 of x squared plus 3. Now, let's have a think about that one. So if we use our change of base rule again on that one, we might just use ln in this case, so we know that it's log of base c. Log of base c of x squared plus 3 over log of base e of 3. And that's our change of base rule. So that's what we want to find the derivative of. So we want to find d dx of log of x squared plus 3 all over log of 3. Now, if you think what we did in the last question, this log or ln of 3 is a constant value that I could pop in on my calculator. So when I differentiate this number is going to still be there. So that doesn't affect how I differentiate the log of x squared plus 3. So think about how we did differentiate this log. It's the derivative on the function. So the derivative of x squared plus 3 is going to be 2x. and my function is x squared plus 3. So if I neaten that up, I've got a 2x on the top line, I've got an x squared plus 3, and all of that's times by log of 3. Now if I check that with my formula up there, would I have gotten that? Let's have a look. Here's my function, I do the derivative on the top line. Here's my function, the derivative's on the top line, yep, tick. Bottom line, log of a, so log of my base. My base was 3, so log of 3, yes, I've got that. And my function is the part in the brackets, which was my x squared plus 3, which is on the bottom as well. So I've got the right answer. So that's why we get that answer, and it's nice to know that as well. Let's have a look below. What we're going to do is express these numbers as functions, these numbers and functions as powers of e to start with. Let's do that. Okay, so we learned how to do this a little while ago. So 2 would be equal to e to the log 2. So in essence, what's happening is our e and our log would be kind of cancelling each other out, and we'd be left with the 2. So that's that as a function as a power of e, basically. So let's see how that is affected by popping an x on that power. So we've got 2 by itself, we've got an x on that power. So we know from the previous question that 2 is e to the log 2. So 2 to the power of x is going to be e to the log of 2 or to the power of x. So knowing when we have a power of a power, that's also going to be e to the x log 2. I'm popping the x out the front because if I pop the x behind it, it looks like it's log of 2 of x. So we're going to do it that way. Okay, now let's have a think of the next one, and then we might differentiate some of these. So 5 to the minus x is equal to, think of what 5 to the minus x is. What's the minus telling us? It's 1 over 5 to the x. If I'm expressing that as a power of e, what I'm going to have is similar to what's happened over here. I'm going to have that as 1 over e to the log of 5 will give me to the power of 5, e to the 5x, and the bottom is going to have x log 5 of x. So what I want to do is going to have a look at part B here again. I want to find what the derivative of 2 to the x is now. So we've found what 2 to the x is in terms of a power of e. Now let's differentiate it. I'll just move down here so I've got some space. So let's find ddx of e x log 2. Okay, so when we differentiate an exponential, we take the derivative of the power, which in this case is going to be log 2. And we write everything back in there again. Log 2 e to the x log 2. This is our answer, but that's not what it looks like in our formula. So what we can actually do is play around with that a little bit. And if I just get my highlighter pen and show you, we can pop our e to the x log 2 in as, if we have a look, here it is up here, as 2 to the x. So I can rewrite that as the derivative of x log e to the x log 2 is log 2, which is up above there, and I've replaced this yellow part here with 2 to the power of x, which if we neaten that up looks a little bit nicer as 2 to the x log 2. And if we have a look at our rules up above, when we differentiated something that looked like this, so differentiating a to the f of x, we got log of a and the derivative of the function af of x, which is basically what we've done below. So I guess with these questions, you've got a choice. You can either understand what they're doing, which I think is very helpful and handy for you guys, especially your extension students, or you can pop the things back in the formula. And the formulas are there on the formula sheet to help you out. So, and we can do that for various questions. So have a go at the questions in the textbook and we'll go from there.